Welcome to this explainer, everyone. Today, we're diving into something I am incredibly passionate about, equipping you, the educators, mentors, and creators out there with the absolute best practices for teaching programming in 2026. We're going to cover the whole shebang, starting from how you explain a single line of logic in a classroom, all the way to scaling that exact knowledge globally on YouTube. Whether you're running a bootcamp, mentoring junior devs, or launching your own channel, this is your blueprint. Let's get into it.
Okay, here is our roadmap for today. We'll start with the modern teaching dilemma, then look at putting logic before code, jump into project-based application, explore the 2026 developer roadmap, and finally, wrap up with exactly how to broadcast your knowledge.
All right, Section 1, the modern teaching dilemma.
So, have you ever run into this? Why does half your class grasp a concept immediately, while the other half is just totally lost? If you've ever taught code, you know this feeling intimately. You explain something, half the room nods along, and the rest are just staring blankly. They usually start off super motivated, but boom, they lose interest the second things move too fast or lack real-world context. The truth is that old one-size-fits-all lecture, it just completely fails modern learners.
It really comes down to contrasting the old way with the new way. The old way relies on passive learning, watching hours of tutorials, hyper-focusing on typing out syntax. It gives this completely false sense of understanding. We call it tutorial hell, right? It's a place we've all visited, but literally no one wants to live in. Students think they get it, right up until they stare at a blank screen. What we really need to be doing is instilling a developer mindset. We need active problem solving, structural thinking, and direct real-world application. Which brings us to Section 2, Logic Before Code.
This is the absolute bedrock of teaching in 2026. You have to get them thinking before they even touch a keyboard. Let's look at how to teach control flow and if-else logic, for example. Instead of just throwing curly braces and syntax on a whiteboard, teach them to think like developers first. Give them a real-world logic puzzle. Ask them, hey, if it's raining outside, what do you grab? An umbrella. Else, what do you take? Sunglasses. Have them write out that pseudocode to actually map the decision tree in their heads. Only after that do you introduce the actual if-else syntax. At that point, the syntax is just a tool to execute the logic they already intuitively understand.
Because at the end of the day, programming is really just solving problems using code as your tool. Syntax is actually secondary. The real goal here is building resilient problem-solving skills. That means explicitly showing them how to break down a massive, complex problem into bite-sized steps. It means teaching them to read an error message without going into full panic mode, which honestly is way easier said than done. We have to teach them how to search for solutions and pinpoint the exact line of code that's acting up.
To pull this off, we need to lean into practices that stop cognitive overload in its tracks. I mean, you can't teach API calls if they don't understand JSON yet, right? You got to break it down. Start with things they know, like a username field on a login screen. And remember, everyone learns differently. Provide written guides, visual diagrams, and hands-on code. Give them specific, continuous feedback. And most importantly, normalize confusion. Tell them straight up, getting stuck isn't failing. It's a completely normal, necessary part of the journey.
All right, let's move on to Section 3, Project-Based Application.
I absolutely love this quote. You cannot learn to swim by reading a book. It totally nails what programming is. You have to write actual code, make messy mistakes, and figure things out on your own. Passive learning just doesn't build lasting muscle memory. Students learn best when they apply what they know to meaningful projects, which, by the way, double as an awesome portfolio for employers later on.
And look at how this builds over time. For beginners, you start small. Think API integration, like a simple weather dashboard. As they level up to intermediate, you introduce CRUD operations and databases, maybe have them build a fitness workout planner. By the time they're experts, they are tackling natural language processing and building AI-powered language learning platforms. The secret sauce here is progressively turning up the dial on complexity.
That brings us to Section 4, the 2026 Developer Roadmap.
It is crucial we look at the macro environment these students are entering right now. The landscape has flipped. Back in the 2010s, it was all C++ and Java, monolithic apps, and those grueling algorithm whiteboard interviews. But 2026, it is incredibly different and, frankly, way more exciting. We're talking cloud-native stacks. We've got tools like GitHub Copilot literally slashing 40% of boilerplate code right out of the gate. Today's developer works hand-in-hand with generative and agentic AI. So what does that essential 2026 stack actually look like? Well, it still starts with rock-solid fundamentals in Python and JavaScript, but then it expands quickly into agentic workflows with frameworks like LangChain. You need to know cloud-native infrastructure, like Docker and Kubernetes, along with CI/CD pipelines. But hey, let's tie this right back to our if-else anchor from earlier. Even with crazy advanced AI agents writing code for you, foundational logic is what dictates how those massive systems run. If you don't understand the underlying logic, the AI simply cannot save you.
Finally, we've reached Section 5, Broadcasting Your Knowledge.
We've got the teaching methodology down. Now, how do you deploy this to the world on YouTube? Well, there are basically 4 types of software channels. Tutorial channels go deep on technical understanding, perfect if you're trying to sell courses. Then you have informational channels, which are great for soft skills and career advice. Live coding is absolutely incredible for building a community because they get to see you solving problems in real time. And then software entertainment focuses purely on the wild outcomes of your projects, which pulls in the widest possible audience.
Now, why even do this? Well, check this out. $15 to $30. That is the premium CPM range, meaning the payout per 1,000 views for coding tutorials. It's huge. Tech education draws a super loyal, returning audience. Between high ad rates, bootcamp affiliations, and course sales, there's a massive financial incentive to share your brain with the internet.
But if you're gonna hit record, you have to optimize. First up, enlarge your code. Sounds crazy, but almost a third of people watching coding tutorials are squinting at a mobile phone. Second, use 2 screens, one to record, one for your script, so you stay on track. Third, and please listen to this one, never ever use background music during a coding tutorial. It is just way too distracting. And finally, physically zoom in on specific lines of code to guide the viewer's eye.
Now, as developers, we love efficiency, right? So here's a magic, zero post-editing workflow for recording. First, open your coding environment and hit record in OBS. While recording, use a tool like Turning Shot to dynamically zoom into the code as you talk. Draw highlights right on those important logic lines we talked about earlier. Then when you're done, just drop the file into Filmora. Use their silence detection feature to automatically chop out the dead air where you were typing or thinking. Boom, you just saved hours of manual editing.
To quote a veteran screencaster, the best edit is the one you never have to make. When you're making educational content, your entire focus should be on teaching the logic and keeping things visually clear. You really don't need fancy motion graphics or crazy post-production to be a phenomenal teacher.
And that brings us to our final thought today. As a developer, you already know how to code. You've got the syntax, the frameworks, the tools down pat. But looking at the future of education, the real question is, are you ready to teach them how to think? By putting logic before syntax, focusing on real-world projects, and leveraging 2026 tools, you can build a true developer mindset in the next generation. Thanks so much for hanging out with me for this explainer. Now get out there and start teaching something amazing.